All right, everybody. I'd like to take a moment and talk about potential energies a little bit. So, if we remember correctly from way back, potential energies are associated with the work done by conservative forces. So, every potential energy has an associated conservative force. The electric force is a conservative force, and it's equal to F equals QE. So that means the work done by moving an object from A to B is equal to Q E B minus A, because that's the distance traveled. Or another way to just say this would be QES, where S is that distance traveled. So the potential energy U is equal to minus Q E B minus A, or Q E A minus B. And we've got to take a minute to think about what this means in terms of the direction that the object moves. So if I have a high potential configuration, does it move toward a higher potential or a lower potential? So let's go ahead and take a look, and we can think about gravity. So if I think about this as being a ball dropped and not an electric charge, when I'm at a high height, I have a potential energy of mgh, and when I let go, it moves toward the ground. So it moves in a direction that decreases the potential. So here I have a high potential when I have Q at A here. And when it moves to the negative side, that means it's moving to a lower potential value. So I'm moving in the direction of from high potential, so high U to low U. And if I had a negative charge, the high U would be here, and the low U would be there. So here I would have high and low U. So that's our sort of general idea here, that I have an electric force and it has an associated potential. Let's talk about, and that means that if I have a charge and there is a potential difference between two sides of, say, a plate, it's going to move in the direction that decreases the potential. And in this case, I also know that I have an electric field here that would be pointing in this direction. So if I want to think about a point charge and the force between 2 point charges and the potential between 2 point charges, I can say, well, I have a force that's equal to kq1 q2 over r squared, which looks a lot like our gravitational law of universal gravitational force, and our law of universal gravitational potential looked like gm1 m2 over r with a minus sign. But here we only have magnitude, so we're not sure if we need a minus or a plus sign here, but it is going to be of this form, and that's because that the potential is actually related to the force as an integral, or we could also say the force is the derivative of the potential with a minus sign here. So we also need a minus sign here. So small calculus aside, but this is the form it's going to take, and we've seen this before, right? So this looks just like the law of universal gravity. So if we want to think about whether or not we need a minus sign there, we can take a minute and plot these two configurations, kq1 q2 over r and minus kq1 q2 over r. So I've plotted them here, and I have the red one as a positive and the blue one as a negative, and I got to figure out which one of these is an attractive potential and which one is a repulsive potential. And I can do that by thinking about the total energy E in the system. So if I'm out here, and in this case, this is X, and this is U, or E, oh no, that's U. So my total energy out here is E, And as I move toward the origin, in the red case, my potential energy increases, which means that my kinetic energy must decrease till I get to this point. Then it stops because there's no extra energy, no energy left but potential, and then turns around. So this would be a repulsive potential. In the blue case, as I move toward the origin, I'm losing potential energy, so U is going down, which means K must be going up. So this is an attractive potential. So if I think about my equation before, I say UE equals K Q1 Q2 over R. When I have like charges, they repel, so the positive version of this should be repulsive. When I have opposite charges, it's the blue one, and that's attractive, so I don't need an extra negative sign anywhere. And that is, in fact, my potential energy stored in a configuration of 2-point charges. If you have any questions, please feel free to ask me, and if you have any other videos you want me to make, please feel free to email me, and I will do so. Thanks so much.